Hi guys, how you doing? It's been a long day for me, and I'm sure it's been for you too. I will try not to make this very boring, and at the same time, I'll try to crack dry jokes so that maybe you guys can laugh a bit. But yeah, today we are going to be talking about observability in mobile applications. Let me just try to present my slide. Network here is. So yeah, the overall idea is that I'm going to walk through observability, how we approach it, and I'm also going to do like a tiny demo session just to show how it works, right? So like the presenter said, money points. Money points means scale. We are building a lot of stuff for millions of users, millions of businesses, and what this means is we have to be cautious. We have to think about them. We need to be empathetic about their experience. Most times as developers, you probably have Starlink in your house or you have MTN 5G. And when you're working on stuff, it happens very fast. And you think, okay, yeah, it works well. It's almost the same way we developers says, oh, yeah, it works on my local, right? But the actual scenario in the field, right, there are people in remote locations. There are people using, for example, money points in remote locations like maybe Ekiti, Kogi State, like not Lagos, obviously, where there's no 5G. So observability and performance monitoring is necessary because you want to know the experience of these folks in these places, right? You want to know how fast your app is when they are using it in these places. So that's basically like the problem, right? So it's a problem of visibility. Usually, I'm just waiting for this guy to load. Oh my God. Yeah, usually, we log, right? What is log? Log is like detailed records of events, right, that happens within our system or our mobile app. And basically like console.log, print line, and most of those things, right? And this is very useful when you're debugging locally or you're trying to get a detail of a crash or something around that, right? For example, there's Crashlytics that helps with that. There's another thing called metrics. Metrics is more of like a numeric measurement about the performance of, please, I need this thing to work. Metric is a numeric measurement about the performance of my system, right? And metrics are good they're very good in situations where maybe you want to measure performance, you want to see like number of people using what you've built and things like that. And basically, like tracing is when you want to measure like the pathway of your system. Like, for example, you are trying to measure how long making a request from an API takes, right? Under certain conditions due to different factors. Like I said before, you are trying to download an image in Lagos with your 5G internet, and you are in a remote place in Ekiti. I'm using Ekiti because I'm from Ekiti. I don't want to insult anybody's state of origin, right? You're in one village, you're in my grandpa's village, you're trying to download the same image. Obviously, it's going to take different times, right? So that's what performance monitoring offers you. Like you're able to have visibility into the app and how it is performing under different factors. So basically, like I want to talk about like the setup and configuration, right? We want to use Firebase performance monitoring in this case. And let me talk about the things that Firebase offers us. It offers us automatic tracing, right? There are some tracing that is inherently part of like the Firebase configuration where you don't have to trace network requests yourself or how long it takes for your app to start or how long it takes for your screen to render. Those are like the default tracing mode that Firebase has provided. Then we can also work on custom traces, right? So Um, okay. So custom tracing is for business critical operations. So let me give an example in the context of like money point, right? A business critical operation would be like transferring, right? You want to transfer from, I want to transfer to my friend. You want to transfer to your friend. You want to send urgent 2K to your sister because she's texting you that she needs money, right? So those are business critical operations. You want to buy lights. For example, last night I was trying to take a shower and I just saw that everywhere just went dark. Apparently, I'm on band A and my light has finished, right? So those are business critical operations. These are operations that you need on a day-to-day, right? So you could work on like custom traces for this. And the third thing is you can see real-time performance of what you've built on Firebase in the Firebase console. So this setup and configuration, I think I'm just going to breeze through this because the network is really messing things up. I will not be able to like download these plugins and stuff. But yeah, I can do like a tiny walkthrough. So adding, this is basically adding Firebase dependency, right, to your Android projects. And that is done here. So I've added it already. This is it, the Google Services plugin and the Firebase Performance plugin, right? And in the app level, you also do the same, just pretty much basic setting up of Firebase. And for my demo, I'm just going to use, I built a tiny app. It's like an image loading app, right? Where you could load like images in three different ways. One is a naive way, right? So naive way of loading image means that we are loading it on the main thread, and it's not supposed to be that efficient, if I'm being honest. The second one is like the optimized way. This way we are loading it on another thread. And the third way is like cached. You are using like a library you are making use of like a cached library that would cache the image, and you don't necessarily need to download it over time. So for the live coding, we'll start by doing I'll just walk you through some custom tracing, right? So this is my adapter. Let me show you what the app looks like real quick so that you have proper picture of what I'm trying to show. Okay, yeah, so this is my app, right? Like I said, we have a naive way. It loads images on the UI thread, on the main thread, right? And it's frowned upon, it's not best practice. Optimized way is using another thread. And in Android development, we use coroutines to switch thread, right? We switch from the main thread to the background thread. And the third one is like the cached image. This uses an image processing library to fetch the image such that it doesn't necessarily have to like re-download the image every time. So that's basically it. So I'm going to do like a tiny walkthrough. This is for naive. So for naive, we can see that I'm configuring like the Firebase trace. That's what I did here, image load naive, and I start the trace, right? When I start the trace, I do everything I need to do, and I stop the trace. So basically, it's like, if I could explain this in a layman term, is, okay, you have maybe 3 siblings, or you have 3 kids, and you want to know the one that maybe plays when you send him to get something, right? So child A, you tell Ayo, child A, to go get bread, and you check the time, right? When you check the time, it comes back after 10 minutes. That's basically like you starting and stopping the trace. You want to know how long it takes, right? Then child B, Bola, you send Bola, Bola comes back after 2 minutes. And child C, what's the name, Chike, you tell Chike to go buy bread, comes back after 30 seconds because Chike is a toddler, he likes running. So he ran and came back, right? So basically, that's the whole concept of tracing. Before you start the particular action that you want to take, you start the trace, which is the trace.start, and when you're done, you stop it. So that way it captures like how long it takes, right? So we did the same thing for optimized. We started the trace. We tried to like optimize it in our own way. We used coroutines to ensure that we are not downloading an image on the main thread, and we display it, right? That's the optimized way. And the third one is the cached way, right? So this cached way, it uses Glide. Glide is an image processing library, right, that leverage, some cache strategies to ensure that images, the first time it will take time the first time you're downloading it, then subsequently, like, it loads it from the cache, right? So it's like some sort of content delivery network or CDN, right, for mobile. And you start the trace, as shown here, and when you're done, you end the trace, right? You stop the trace. This is it. This is also another place where it is stopped. And yeah, that's basically how custom traces work. As shown here, you start, you perform the action you want to perform, and you stop it. It's basically like as simple as that. Now I want to try to load. Okay, let me just leave it like this, because if I try to load, the network will be bad. We can see like three things, or we can see image load optimized, we can see image load naive, and we can see image load cached. So we can see like the average duration that it takes. So over 24 trials, we can see that the cached one, which is supposed to be like the best one in this case, takes 601 milliseconds, while the naive one takes 6.1 seconds, and the optimized one takes 6.45 seconds, right? So I will explain why optimized takes a longer time than cache, and that would also help us like to appreciate tracing a bit more, because you can't just make assumptions. So, but as you can see, the cache takes way less time because you don't have to download again, right? So for naive is expected to take time because it happens on the main thread. I also added like some sort of delay just so that I can bring my point home, really. Then for cached, you might want to ask me that why is optimized taking time? Because optimized is not done on the main thread, right? And that's where you would see, I will just show you one or two things. You could say that we are trying to start a coroutine. So a coroutine is what like takes the process to another thread, right? So the process of you like starting a coroutine takes time, and when you start the coroutine, you start tracing, you try to connect to download, then the delay, then after downloading, you try to decode the image byte array that you downloaded, right? And if you notice, we have delay twice here. We are delaying twice. Why? I mean, we are decoding twice. One, to get the size of the image, and second, to get the actual image, right? And at this point, too, you could see that we are trying to switch again from the background thread to the main thread so that we can show the image, right? So what this is basically saying is that this individual process, the process of you moving from the main thread to the background thread, using coroutines to switch, decoding images twice, it takes time. So it's not necessarily like a factor of, oh, I'm not loading on the main thread, right? I'm not loading on the main thread, so it should not take time. No. Sometimes when you load in the background thread, you could also be doing some things. You could also be making some wrong decisions that would still make like your program or your code to take time, as shown here. So that's why you would say that optimized is even taking way more time than the naive way of loading the image. Meanwhile, cached is just sweet. Cache is just using the image processing library to download it, and also making use of like a cache strategy to ensure that it doesn't download over time. And we can see that here. So let me move to one sec. Yeah, let me move to something else. Custom attributes. So you could add attributes, right? And the reason for attribute is for context, right? For example, I'm trying to, let me take this one to like a real life example. I'm trying to know how long it takes for me to transfer money to my friend or to my sister, and I can see that for some time is really fast, for some situations it's really slow. So attributes in this case helps me to understand the context that, okay, why is it slow in some cases, why is it fast in some cases, right? And I could put like attributes, the network provider, right? So I could check that, oh, the one that is taking time, the network, or the time that this transaction is taking time. When I filter by network provider, I could see that, oh, maybe I'm using Glow, or I'm using, what did I just do? Yeah, maybe I'm using Glow, or I'm using Airtel. Those are like the networks that I usually want to take my life, right? So basically, attributes adds more context for you to understand why, rather understand why the the code or the system is performing a certain way. So in this case, I just added like attributes like the loading mode, right? So I want to know if it is the cached mode or the naive mode or the optimized mode. Then another attribute is I want to know the number of images, which is what I'm doing by doing image URL size, whatever, right? So this gives me context. This gives me context like, oh, it's because I'm trying to download 50 images here compared to downloading 100 images there. That's why it's taking more time. So basically, attributes helps you to add more context for you to understand, and even for other people to understand. I could show you, yeah, so these are like examples of me using attributes, right? I'm trying to say, okay, the library is glide. I'm trying to say the loading mode is cached. So that means I can basically come here and, oh God, I shouldn't have done this. I shouldn't have done this. But yeah, I could basically come here and filter by attributes and see how long some of these things are taking based on the attributes, right? So yeah, that's that. Then tracing network requests. Like I mentioned before, network request is inherently part of Firebase. This thing is not loading, and it's really. I want to check if my phone has a better network. No, it doesn't. I would have shown the fact that network request inherently is tracked by Firebase. You would see how long your app is taking to communicate with like a backend service, a backend API, right? If there is an API that is taking time, you can basically see it on the Firebase console, and you can know how to like debug or know how to communicate with the team that would help you with debugging. So that's what the network request helps you with. So there are best practices, right? And I'll start with like the do's. It's important to keep the trace name consistent and descriptive. It is important so that somebody can, another person can come and check the code and understand like, oh, what's this trace doing, right? Let me show an example here. Okay, yeah, so this is an example of a trace, right? It is, in a way, it is descriptive. If anybody checks out this code, the person will know that, okay, this trace is for us to keep track of loading, of image loading, right? Image downloading, the optimized way, right? From here, you could see that, okay, this is a way to ensure that the person that checked this code know that this trace is keeping track of loading image the naive way, right? So you need to keep trace names consistent. You don't just say image load, or maybe image load 1, or image load M1 or 1B or whatever. That's not descriptive enough. And people start asking questions like, okay, what does 1 mean? What does this mean, right? So that's one thing. Another thing is using custom attributes for filtering. Just like I said before, it is very important to use custom attributes to add context, to understand why some things are taking time and other stuff like that. Then another thing is to track business critical decisions, right? It's not encouraged for you to track things that don't matter, things that they are not like critical operations. For example, I would say, let's use WhatsApp for example. Maybe Blocking people is a critical operation. I would say, what's something that is not? Okay, maybe changing your status, right? Is not a critical operation. Changing the status on your WhatsApp, right? Compared to texting. Texting somebody is more critical. So if you were to trace WhatsApp, it's advisable for you to track or to trace the operations that are critical for the business, like sending voice notes, like group call, like video calls, like sending text, rather than things like posting a status, right? So that's what critical operations means. Then also monitor screen rendering traces, especially for people that do heavy UI stuff. You want to know how long it takes to render like the UI, the animation on your screen. Then this is another way of tracing. It is called tracing with annotation. This is way easier. Like you don't have to call start or call stop. By just calling this trace annotation with the actual name of what you want to trace, you just it's quite easy. You trace and it automatically starts and stops it for you. The only bad side to this is that it doesn't have attributes. So an example of where I did that was in this place. Yeah, I tried to use the annotations to trace preparing image URLs to be displayed. But the network is shitty, so I can't show you that on Firebase. Yeah, so this is another way of tracing. Tracing custom, using the custom way, where you call the start and the stop. Then you could also trace with annotation, where this one automatically calls for you. The only con of this is that you cannot add custom attributes. So what are the don'ts? Don'ts is avoid high cardinality attributes. So attributes like tracking a user ID or tracking somebody's password or tracking somebody's email, that's not necessary for your system. You don't need that information for anything, right? Also, it's not advisable to create many traces. I would say that, as I've shown before, the optimized approach where I was creating coroutines at different points, I was also decoding. I decoded twice. I decoded an image twice, which is not nice, by the way. That's basically doing. It's an overkill, basically, right? And what it's also saying is that tracing itself takes resources, right? What it's also saying is that tracing itself, it's a resource-intense activity. So, in as much as you are trying to trace, you want to try to understand what's going on. It's also important for you not to over-trace, because that would make your app slow. It will make your system slow, basically, right? And that's why I mentioned initially that it's only business-critical operations that should be traced, not just anything. Things that users will use and they don't really care about, right? It's fine for you not to trace it. It's the part that are really important. That's the part that you trace, which brings us to the next point. Don't trace every method. Focus on important operations. And when you're using custom traces too, it's important to stop traces. Ensure that you stop it, because when you don't stop it, it causes memory leaks, and that's bad for your app. So what are the key takeaways, right? The key takeaways of this is Firebase tracing or Firebase performance monitoring provides automatic way of tracing through annotations and a custom way of tracing as well, right? Where you can start it, add some attributes, and stop it too. You can basically do different things. And custom tracing, like I've shown, helps you to monitor business critical operations. You can add attributes to these traces to help you get context of what you're trying to trace or the behavior of the different people using your app, right? And that's number 3 anyways. Then you use number 4, that's add trace for method level tracing. You just want to trace something real quick. You don't really want to get much context about what you're tracing. That's when you use the annotation tracing. So it's always important to balance observability with performance overhead, which is also what I've mentioned. When you want to trace, you don't over-trace, right? So yeah, that's it. Additional resources, basically Firebase documentation, and there's also sample projects on GitHub, and my sample project, so I'm also going to push it on GitHub and post about it. So yeah, that's it. took way less time than I thought. The network actually has messed me up. But yeah, that's it, and thank you very much, guys.